All right. So the lady says we're recording. She wouldn't lie to us, at least not inadvertently. So we are recording. Okay. Let me go ahead and bring up the problems that we didn't get to last time. And I'll share those with you all. So sorry, this is so cumbersome today. Zoom's just not being my friend. Okay. All right, so just making sure, can everybody see the screen that has the problems that the guided notes from last time? Just making sure that that's good. Okay, cool. Thanks, everybody. Appreciate it. All right, so I think last time we were able to compute the correlation coefficient for this HDL and age of the male. I think we got like a 0.85 or something like that, a pretty strong association between the two variables. But we did say that we probably need more data to make a conclusion. All right, so for today, what we're going to do is we're going to finish up and we're going to do one more example of correlation and association that kind of encapsulates everything that we've done in this section. Okay, so in July 2013, a study was conducted regarding the website ratemyprofessor.com, determined if there's an association between the overall average rating of quality that a teacher received and then the percentage of respondents that indicated that that teacher was hot. All right. I think since then they've gotten rid of the option to rate the teacher as hot or not or something like that. So whatever. So below are 6 randomly selected ordered pairs of such data. Okay. And if anybody's ever logged on to Rate My Professor, you know that the lowest you can get is a 1, the highest you can get is a 5. And they used to actually give you the percentage of people that said you were hot, and they actually used to have a chili pepper, and then the chili pepper would have various degrees of flame to it. So the more inflamed your chili pepper was, the hotter that professor was. So they got rid of that. So unfortunately, you can't rate if they're hot or not anymore. So regardless, we're going to go through and essentially do a problem that's very similar to what's going to be on your homework that's going to be due for the quiz number 2. So we're going to define the explanatory and response variable, which should be pretty easy. We're going to construct a scatter plot. We're going to describe the type of association. All right. If it's linear, also describe the strength and direction. If the data is linear, we're going to compute R using only the formula. Okay. And that's going to be the painful part, right, folks? We remember at the end of class last time that computing R was not fun. And then we're going to interpret R. Does the value computed for R correspond to the scatter plot? Why or why not? Are there any lurking variables? Okay. And if so, we're going to list some. And then using everything above, state a conjecture relating the average rating of the teacher and the hotness percent. All right. So let's just remind ourselves of the correlation coefficient formula, which is up here. All right. So I'm going to copy and paste this animal because we are going to need it later. And I'll just cut and paste it and put it there. Okay. All right. So let me go ahead and ask you fine folks, what is going to be the explanatory and the response variable? All right. So if anybody wants to drop it in the chat, if they think they know which one's going to predict the other. All right. So I'll give you all a second to think about that. Or if you just want to say it, that's fine too. So percent hot explanatory or the rating explanatory. Yeah, this one's a tough one, isn't it? It's kind of tough because the rating could predict the hotness or the hotness could predict the rating. I think in this example, I personally, I wouldn't care which one you used, okay? I think what we're going to do is let's use the hotness to predict the rating of the teacher, okay? Because I think in this example, what they're suggesting is that, oh, I'm sorry, the other way around. The rating would predict the hotness, okay? So let's say that the explanatory would be the rating, and then the response would be the hotness rating. Okay. Okay, whatever you want to say. Although you could make an argument either way for it. And of course, this example is pretty trivial, right? It's not like, we're trying to do medicine or cure cancer or anything of that nature. Okay. So for those of you that might have thought, okay, the hotness is going to be the explanatory variable, that's okay too. Okay. I could go either way with it. No matter what, you guys are still going to get a good, strong association between the two variables. Okay. On the examinations and on the quizzes, I'll make sure that it's pretty evident which one's which. And of course, if you guys have a question, you could just email me and ask. Okay. All right. So now we're going to go ahead and construct a scatter plot for this. Okay. So let's go ahead and do that. I'm going to go ahead and flip over to my other computer real quick so I can draw the whiteboard here. All right. So for our scatter plot, okay, what we're going to do is, since we said that the rating, so we're going to draw this. All right. And I'm going to make the x-axis the rating. Notice that it goes from 1.5 to about 5. So I'm just going to do increments of 1, 2, 3, 4, 5. Okay. And this is my rating. Right. And then notice that the hotness percent goes from 4 to 53. So maybe what we can do is we can just do increments of 10 and make those up to 60. All right. And there's no one right way of doing this. There's lots of right ways to do it. I always just think of the laziest way to do it, I suppose. All right. And that's our percent hot. Right. And then if we plot these, we get a 1.5 comma 4. So that might be right about here. And then we get a 2.819. So that's going to be right about here. Right. 3.428. So right in the middle of the 3 and 4, and then up to 28 might be right about here. And then we have a 4.131. All right, so maybe right about here. And then 4350 or 4.345. Okay, so 4.345, maybe right about up here. And then finally 4.853, maybe right about here. All right. Again, when we draw our scatter plots, they don't have to be perfect. All right. But after we're done, they should give us a pretty good indicator of what the association looks like for this. Okay. All right. So any questions I can answer for folks about being able to construct the scatter plot? I'm assuming for everybody, this is a really easy task for you guys. All right. But questions about that, you can either drop them in the chat or shout them out. Okay. Folks. So next thing that we need to do with this problem is we need to describe to determine what type of association we have. And then also, if it's linear, to determine what the strength and the direction is. Okay, so could somebody tell me what type of association we have? Okay, in other words, what shape does this look like it's trying to form, or what's the best shape that it's trying to form? And remember, there's only two associations that we get. We can either say linear or nonlinear for our class. Okay, so yeah, Cassidy, I mean, can everybody see that this is clearly linear? All right, I don't think there's a better shape. Okay, nice, Kay, good job. All right, so this is absolutely linear. All right, in fact, this is about as linear gets. Okay, all right, so if I was to ask you for the strength and then also the direction. Let's start with the direction, because usually the direction's a little bit easier, okay? Direction is either positive or negative, okay? So can somebody tell me what they think that the direction of this association is going to be? Okay, yeah, Oliver, yeah, okay, perfect. Can everybody see that this is going to be a positive association? As the rating gets higher, the hotness percent gets higher too, okay? So it's definitely positive. I'm positive that it's positive. Worst joke of the day so far. All right. What would you say about the strength? And there's three ways that we can identify the strength or characterize it. We can either characterize it as strong, moderate, or weak. All right. And that's probably the most ambiguous of the three. So somebody tell me what they think about the strength of this. Okay. So Lots of people think it's strong, okay? I think it's strong as well, okay? The closer it is to forming a perfect line, the stronger it is. Everybody's good with this. Okay, so in fact, once we get the correlation coefficient, it's going to prove that this is probably the strongest association we've seen this semester, or we might see this entire semester. Okay? All right. So any questions about how to identify the association, linear or nonlinear, the strength, strong, moderate, or weak, and the direction, positive or negative? Okay. All right, friends. All right. So if the data is linear, which it is, okay, we all agreed that it was, or if we didn't agree, then we didn't say anything. That's fine. Be able to compute R using only the formula. Okay, so this is the painful part of the problem. Okay, and on your guys' examination, this is going to be worth 10 points. All right, so I always ask folks to be able to compute R. All right, just one of those things we have to do. Now, if you remember from Wednesday, the first thing that we did was we kind of rewrote the data into a vertical format. So we had X and Y. And the X data, I'm just going to use as the explanatory variables. So that's going to be our 1.5 and our 2.8 and our 3.4. Oops. And our 4.1, 4.3. I think 4.8 was the last one, right, friends? All right, cool. And then for Y, we have 4, and then 19, and then 28, and 31, 45, 53. That's a 45 in English. Sorry about that. There we go. Okay. Now, you might remember that if you look at the formula, all right, and you might not want to because it's scary, we needed 3 other columns, okay? And you might remember one of those columns was XY, okay? Another of those columns you might remember was X squared. And then the final column was Y squared, okay? All right. So what we're going to have to do is we're going to have to fill in those columns. And remember, to get XY, all we're going to do is we're just going to multiply these columns right here, the X and the Y column, okay? So for instance, for the first one, we just multiply 1.5 times 4. That should work out to be 6, okay? Now I'm going to grab my calculator and I'm going to work this out. But if you guys could verify this, just because I'm going to be typing and writing at the same time, I would really appreciate just to make sure that we're good to go. Okay, so I get 2.8 times 19, 53.2. And then 3.4 times 28, I got 95.2. Right, and then 4.1 times 31, 127.1. 4.3 times 45, I got 193.5. And then finally 4.8 times 53, I ended up with 254.4. All right. And again, if you guys could just make sure that these look okay, I'd appreciate it. Okay. At the end, if someone, okay, cool. Thanks, Luke. I appreciate that. Okay, nice, Cassidy. Thanks. All right. For X squared, I know the first one should be 2.25, or at least I'm fairly confident in that. 2.8 squared, I got 7.84. And 3.4 squared, I got 1156. And 4.1 squared, 1681. 4.3 squared, 1849. And then 4.8 squared, 2304. I think that's the year that if I keep saving, I'll be able to pay off my student debts. All right. Just to verify. Okay, thanks, Luke. Nice. Okay. For the Y squareds, I know 4 squared is 16. 19 squared is at 381, I think. I'm going to check just because it's Friday and my brain's 361. All right. Good thing I checked. I really need to go back through and memorize my perfect squares again. 784. 31 squared, I got 961. 45 squared, 2025. next year. And then 53 squared, 2809. All right. So, do any of those values, okay, thanks again, Luke. Okay, so it seems like Luke got all the same things, so I'm good as long as one other person got the same stuff. All right. Now, if you guys could be so kind, just randomly pick one of the columns and add that column up. I'm going to pick y squared because it looks, or I'll pick x squared because it's got the decimals in it. If everybody else could randomly pick one of the other four columns aside from x squared and add it up, then we can move on. Okay. I got 79.99. Okay. And then did anybody else get any of the other four columns? Okay, so y squared 6956. Okay, 6956. If I could write in English today, sorry. All right, and then Carter XY 729.4. Thank you. And then X 20.9. Thanks, Haley. All right, and then we just need that lonely Y there. I'll start adding it, but if somebody gets it first, let me know what they get. All right, I got 180. I don't know if anybody else got the same thing, just to verify that I'm not lying to you inadvertently or on purpose. All right, we'll go with that until somebody tells me no. Okay, nice. Thanks, everybody. Okay, cool. So that was moderately painless. I know the virtual thing is just so weird. Like, you guys are really good about helping out, so I really appreciate that. Thanks, everybody. Okay. All right, folks, one more thing we need before we start throwing it into the formula is we need n. Okay. Can somebody tell me for this problem, and you can just drop it in the chat, what did you get for n in this case? Or, I'm sorry, what would n be in this case? Or what's the value of n instead? Not like, so 186. Okay, nice. Thanks. Yes, it's the number of ordered pairs is n. Good stuff, folks. Okay, so that's going to be n is equal to 6. Perfect. Good job, everybody. Okay. All right, and we get that because there's 1, 2, 3, 4, 5, 6 pairs of observations, right, folks? Okay. Sometimes, and I think I mentioned this on Wednesday, sometimes students think that n would be 12 because there's 12 numbers in the original variables, or the 12 numbers for the original variables. All right, but it's 6 ordered pairs. Okay. All right, folks. So now we're going to throw this into our formula. Okay. So hopefully you have the formula present, but remember, the first thing that you guys do is you're going to go ahead and say that r is equal to n, which is 6, times the sum of xy. Okay, so sum of xy, we got to be 729.4. Okay. Now from that, we're going to subtract the sum of x times the sum of y. Okay, so we're going to go back and we're going to take these two values. Okay, the sum of x, sorry, I have to move my screen just a little bit. So we're going to take these two values and multiply them together. Okay, so the 20.9 and the 180. All right. Now from there, that's where we have to do the 2 square roots. Okay, so that's going to be 6 times the sum of x squared. And you might remember last time what I suggested is that you pick the one that's bigger. Okay, so if you look at the 2x squareds, if you can't remember the sum of x squared versus the sum of x quantity square, you just pick the bigger one here. Okay, so, and it might be helpful just to kind of box things off as you use them. Okay, so that's going to be the sum of x, or 6 times the sum of x squared, minus the sum of x, 20.9, and square it. Then we're going to multiply that by the same thing with the y's. Okay, so that's going to be 6 times the sum of y squared. And if we go back the sum of y square was 6956 minus the sum of y, which is 180 quantity square. Okay, and once again, you take the bigger one. Okay, so you take the bigger y first. Okay, all right. So this number right here, by the way, that's, oh boy, I think I just made it worse. That's 79.99. Okay, so sorry about that. I'm writing on my Surface as I'm looking through things. I'm looking at the bigger screen, which is more reflexive of what you guys have at home. So sorry, I know it's a bit of a mess. You can just write it on the teacher evaluation at the end. Needs to use some stencils, get some handwriting classes, something like that. Okay. I don't know if that made it any better or worse. All right. Now, remember, folks, what you're going to do now is you're going to start by computing the numerator. Okay, so at this point, we're going to compute the numerator. Then also what we're going to do is we're going to compute what's underneath the radicals. We're not going to compute the radicals themselves, just what's underneath the radicals. All right. And I'm going to go ahead and do this. And if you guys could verify for the numerator, I end up with 614.4. Okay. Under the first radical, 6 times 79.99 minus 20.9 squared, I got 4313. And then for the last radical, 6 times 6956 minus 180 squared, 9336. All right. Okay, cool. So did anybody get anything different than those three numbers? Okay, looks like you got the same card, you got the same. Nice. Okay, cool. All right, folks. So at this point, now we're going to stick it on our calculator all at once. Okay. And let me just remind you guys, and by the way, if you're having trouble getting these out of your calculator, when we're done, you can just stick around and I'll be happy to show you how to get them out of the calculator. Okay. Folks, so the last thing we're going to do is to shove this into the calculator all at once. And here's how you do that. You're just going to type 614.4 divided by the square root of 43.13 times 9336. Okay, and that should give us our approximation. All right. Remember, folks, you only type the one radical. It's a rule of algebra that it's okay if you have two of the same radicals with the same indexes, in this case, square roots, it's okay to multiply those together. Okay, so 614.4 divided by, I'm just doing this, 43.13 times 9336. All right. I got 0.9682. And I forgot to put that decimal in there. Okay, and Cassidy got the same thing. Nice. Okay, everybody looks like they got the same thing. Nice. Thanks, everybody. Appreciate it. Okay. Seems like a lot of work to get a 0.9682, but it is what it is. Okay. All right. So let me go back because this is clearly the most difficult part of the question. But are there any questions about filling out the table? All right, because that's just literally multiplication, squaring, translating, making it go sideways. All right. And then any questions about being able to get any of the values from R? And I'll pause and I'll wait a moment. I'll check the chat just to make sure everybody's good with this. Okay. All right, folks. So the good news is we're done all the tough stuff. Now all we have to do is just analyze this. Okay. All right. So for the next part, okay. Oh, right. Yeah, it does see it's so close to a perfect line. Yeah, that's absolutely right. Yeah. In fact, remember the other one that we did on Wednesday, it wasn't even close to that, right? Okay. All right, good observation. I'm going to switch back over. I think I'm going to. Hold on a sec. Sorry, folks. Let me stop. There we go. All right. And There we go. Okay. So now we're going to go ahead and interpret R. Okay. And remember for R, we get 0.9682, I think it was, right? I'll put that in parentheses just so we remember it. So that is to describe what the correlation coefficient suggests regarding the average hotness and percent. All right. So does anybody think they might know what does 0.9682 tell us about the association? All right, and I'll check the chat too. So sorry about that. I'm again bouncing things everywhere. Yeah, excellent, Carter. It tells us that it's an almost perfect, that it's very strong and positive. It's almost a perfect association. Yeah, excellent. Okay. So this tells us two things. It tells us that the strength is very strong. Okay. I'm going to put in parentheses. I think Carter said it really nicely. That it's almost perfect. All right. And it's almost perfect because it's really, really close to +1. The closer you are to +1 or -1, okay? In fact, anytime you're either positive or -1, that means you have a very close to it. That means you have a very strong association. Also, you can say that it's positive, okay? Okay, and the reason we say it's positive is because 0.9682 is positive. I just want to make a note here. We cannot say that this is a linear association from R. Okay, so try it one more time here, and then if it doesn't work, let's try this. No, okay. So we cannot say that this is a linear association just from looking at R. Okay, but we can say this from the scatter plot, which is why we do the scatter plot. Okay, the scatter plot gives us a good benchmark as to what to expect. Okay, but it doesn't necessarily tell us what type of association we're dealing with. Okay, so very nice. Good job, folks. Any questions about being able to interpret R? If I give you the number, that you guys are okay being able to tell me it's strong, moderate, weak, positive, or negative? All right. Does the value you computed for R correspond to the scatter plot? Why or why not? Okay. If you guys go back and look at your scatter plot, I think it's pretty obvious that we said, in fact, I think we said that we said that the scatter plot was very strong and very positive for the association. Okay. So the way I would say this is yes, both the scatter plot and R suggest that this is a strong positive association. Okay. And it's good to have both of those. Okay. Because if one contradicts the other, then that means we might have made a mistake somewhere. Okay. All right. So that's easy enough. All right. Are there any lurking variables that could explain the relationship between average rating and hotness percent? Okay. And if so, list some. All right. So, any thoughts about those sorts of lurking variables? And just to remind you guys, lurking variable is a variable that really has influence over both of those two. So, any thoughts that might be like like subjectivity? Yeah, I think that's good. Like, how does one interpret, beauty is in the eye of the beholder. Okay. So, you know, if someone subjectively thinks the teacher is attractive, it may influence the rating. Okay. Any other ones anybody want to throw out there? It's kind of gender. Yeah, I think that's a good one. Okay. Yeah, absolutely. We can, and this sort of goes back to, I don't know if you guys have ever heard this study before, but there was a study done about female and male waitresses or servers, and by and large, male servers always got higher tips, like no matter what the restaurant was, whether it was Waffle House or a five-star diner or five-star restaurant, whatever it might be. All right, it's actually the same thing is true in teaching. Generally, male teachers are looked at, they get more favorable reviews. All right, I've actually compared my reviews with some of my female colleagues just to kind of verify this, and also some of my other colleagues that are males too. And generally, males get higher ratings than females do. Totally unfair. All right, because I've had lots of really great female teachers, but I don't know what it is. It's part of the male bias. Yeah, yeah, absolutely. It's crazy. Like I would have never thought that. And there's been research studies to suggest this sort of stuff too. So anyway, but yeah, that's a good one, Kay. Smart. One that I thought of that actually that kind of links to attraction and also effectiveness as a teacher is, I think, empathy and kindness. And I'm going to throw that out there for mine. All right. Um, Usually, one if you go through the list of qualities that you would want in a teacher, most people will want to say understanding, compassionate, kind, those sorts of things. All right. I think if a teacher is generally of that ilk, that they usually get better ratings. So, for instance, if you forget to do your homework sometime or you're unable to turn it in, the teacher's like, yeah, just go ahead and turn it in the next day. That's fine, or something like that. Or, if you're having trouble with something and the teacher's approachable, that might boost their rating, even if they're really not a good teacher. All right. So, I mean, quite honestly, they might not be able to teach you anything, but they might be nice, and that kind of offsets it. Same thing for attraction. All right. We're generally not attracted to people that are not kind. Okay. So, that might be like one of those sorts of lurking variables, something that affects both of those, but we don't necessarily think about it. So, just food for thought as we're thinking about these lurking variables. All right. So aside from all that stuff, let us use everything above to state a final conjecture. Okay. So what do we think, folks? Do we think that that the average rating can predict the hotness? Or is this just kind of like there's not really evidence to suggest that? So yeah, I would think that based on both the correlation coefficient and the scatter plot, that there's some good substantial data to suggest that there might be an association. Okay, so based on the strong, keep spelling strong wrong, association demonstrated by the scatter plot and R, we can say that there is some evidence to suggest an association between the average rating and hotness percent. Okay. Hotness dollar, right? Hotness percent, sorry. Percent dollar right next to each other. All right. However, what's one caveat that we have to keep in mind here when we're making these associations and conjectures? Yeah, you got it, Carter. You got it, Luke. Sample size, right, folks? How many observations did we have? We had 6 observations. All right. People do this all the time. They pick the 6 observations to get the conclusion that they want. Okay. So we would absolutely need more data to make a stronger conjecture about this. Okay. So we need more data to make a stronger conjecture. Okay. All right. Just by the way, in real life, sometimes folks consider 30 to be a good sample size. All right. Sometimes I guess it just depends, but usually 30 is not strong enough, but at least scientifically it's a basis. Okay. So when I ask you guys to do your capstone projects, it's probably going to be more around 100. All right. And that's just for a few reasons. Number one, attainability in time. But number two, I want to make sure that you guys have enough data to get rid of some outliers, et cetera. All right. But I know that's a long way away, but I just want to kind of mention that. All right. So before we go on, any questions I can answer for folks about being able to go through and do any of this business with respect to association, correlation, any of the analysis stuff? All right. Okay. If you guys have questions, okay, you guys can certainly ask me over the weekend. Okay, I'll be happy to answer whatever I can, or you can just bring them to class on Monday. Okay. So let me close this out since we are done with it. Okay. And the next thing we're going to do is we're going to go ahead and take a look at how to work through our first technology assignment, excuse me. All right, so let me close all this stuff out. Sorry, I know I'm talking to myself while I'm doing this. I apologize. Stop here. All right, I want to show you guys where to actually go to get the technology assignment stuff. Okay, so in Blackboard, I'm going to pull it up, the actual assignment too. But what you guys want to do when you're ready to go to do it is you're going to go all the way over, you're going to go to your course, and you're going to go to where it says Documents, Quizzes, Technology Assignments. And then you'll scroll down to where it says Technology Assignments, surprise. And then here that 3 of the 4 of them are out there. I still have to post the last one, which I will. And what I've done was I've posted the data as well as the assignment itself. Okay, so I'm going to open both of these just to show you what they look like. Okay, so the data itself, and you shouldn't be typing in the data into Excel or anything like that, but this is what the data looks like. Okay, so you shouldn't have to go through, you shouldn't have to type this in. And then exercise 2, because there's 2 exercises, is over here on this tab. All right, so for those of you guys that have never used Excel before, each of these little blocks is called a cell. Down here, these are tabs. All right, so these basically are the same thing. If you ever want to put another tab in, you just click on the plus. Okay, if you ever want to delete it, you just right click, click delete. All right, not that you'll have to do that, but all right. Now I'm going to use a different set of data from the problem I'm going to show you guys, but I want to show you the actual technology assignment itself as well. All right, so let me bring that over. All right. So the assignment itself, this is the data that I just showed you. Okay, so you shouldn't be typing in this data into an Excel sheet. It's already there for you. Okay, and we're going to do a lot of the same things that we've already done in the class, but we're going to use Excel to do them. Okay, so essentially what we're going to do is I'm going to show you guys how to get a frequency distribution, a bar chart, and a pie chart, and then for quantitative data, how to get frequency distribution, central tendency, measure dispersion, histograms, and box plots. Okay, so and these are transferable to pretty much any class that you have to do something with respect to data in. Okay, so these are probably like some really good fundamental skills for you guys to have, especially for those of you guys that are going on to get master's degrees and have to do research stuff. Okay, all right. Now let me show you first for quantitative data because that's the tougher one, how to go through and kind of work with that. All right, so I'm going to pull up some data here. All right, so I just made up some data. I have some malfunctions at 2 different manufacturing plants. All right, let me move this over so that way we can see it. All right, and this is very similar to what you guys are going to have to do for the technology assignment, except you guys have 3 things to worry about. All right, let me show you all how you're going to go through and get the frequency distribution first. Okay, so what I'm going to do is let me blow this up so that way you guys can all see it. Okay, the first thing you're going to do is you're going to use Sturge's rule to be able to figure out the number of classes and the width. Okay, you can do that right in Excel. Okay, so to figure out n, here's how you're going to do that. You're going to do this equal count A. okay? And then you're just going to highlight the data, and you're going to close the parenthesis, and you're going to hit enter, okay? Oh, I spelled it wrong, sorry. Okay, so equal count A, highlight the data, hit enter, and that'll give you that there's 27 observations. Okay, so again, all you do is in any blank cell, you just hit equal count A, and then you highlight all the data. Okay, to figure out C, you're going to say equal 1 plus 3.3 times log, all right, and you're actually going to do log 10. Okay, so in your calculator, it's a little bit different. And if you want to do this in your calculator, that's fine too. Okay, I'm just showing you guys if you just wanted to use Excel how to do it. And then you just type in the 27. Okay, I'll do this again. And we end up with 5.7235. So again, you type equal 1 plus 3.3 times log 10 parenthesis 27. All right. Finally, what you're going to do is you're going to find the width. Okay, so W. And remember, for W, it's high minus low divided by N, or I'm sorry, divided by C. All right. So in this case, I'm going to say equal parenthesis. Now, notice in this data set, it's pretty easy for us to identify the highest number, which is 20. All right. So it's going to be 20 minus the lowest number, which is 0. And I'm going to divide all of that by C, which is 5.7235. Okay, now that gives me 3.49. And if I round that, that's going to round to 3. Okay. All right. So once again, let me do that again for you guys so that way you can see like what I did there. Okay. So I'm going to do equal parenthesis 20 minus 0, close parenthesis, divided by 5.7235. Okay. All right. And then you just round it down to the next integer. Now I'm going to move all this stuff because I'm going to do one other thing to make this a little bit easier on us. Okay. But any questions I can answer about how to use Sturge's rule in Excel so far? And remember, we are recording this, so you can go back and you can look at it over and over and over again. So you can just rewind it, and you can rewind it again and rewind it again. And if you need to go to sleep, you can, just listen to me. All right. Another thing that's going to be helpful is if you put all of this data in a single line. Okay, so I'm just going to take and I'm just going to cut and paste this. So what I did there, let me just go ahead and show you what I did. I highlight the data, and then you can right click and you can cut, and then you can click in the box, and then you can right click and you can paste. Okay, and there you go. So you could just go ahead, you can highlight, you can right click, cut, go down here, right click, paste. Okay, and so what it'll do is it'll put all your data in here. And then what you guys can do is you can sort the data, all right, which is really nice because then it puts it from high to low. All right, so I'm going to highlight all this data. If you go over to here where it says data, and then right here, you click on this A to Z, and I'll do it again so that way you can see it. It'll put it right in order for you, okay, which is really nice. So think about if we had to do that by hand, okay, that would take a long time. All right, so let me do it again just so I can show you guys everything. All right, so if the data is not in order, which it won't be, you just highlight it. You go over here to this data tab at the top, right? And then you just click on A to Z. If you click on Z to A, it'll do it from highest to lowest. If you click A to Z, it'll do it from lowest to high or lowest to highest. Okay. All right. Does that make sense to everybody? Any questions I can answer about going through and doing the date, like the initial data stuff before we make the classes? Okay. All right, folks. Now, at this point, we're going to make our classes, okay? And then we're just going to figure out how many observations there are in each of the classes, okay? So let me check the chat real quick. In the assignment, there are 3 rows. Are we allowed to move them? No. So, Luke, what you're going to do is you're just going to have 3 different rows, okay? Oh, hold on. Let me make sure that I'm not lying to you. So in the actual technology assignment. So let me go there. So they're already done for you. Okay, so this is like one column, this is another one. So it's already done for you in the actual assignment. So you guys don't have to do this. The only thing you guys have to do in the actual assignment is you just have to highlight the data and you just have to go to data and do that. Okay, so you just sort it. Okay. And then you'll highlight it again. It'll give you an option, by the way, if you click on this to expand the selection, just click on continue with the current selection. Okay, it's okay, Luke, no problem. It was a really good question because I know like in the actual Word document, it's 3 different columns of stuff. Okay. All right. So this is exactly what you guys are going to do in the actual assignment. Okay. You're just going to go ahead and just sort them like that. Okay. All right. So let me go back to the other stuff that we were doing. So now what we're going to do is we're going to go ahead and make our classes. And then we're going to have the frequency. Okay. So remember, our classes have a width of 3. Okay. So the lowest bound is 0. And then remember 0, 1, 2. So that's a 3. Okay. So sorry. I know I put my grotesquely large fingers up to the screen. So it should end up at 2. Then we have a 3 to 5. All right. So remember 3, 4, 5. Okay. So that gets you 3. Oh. By the way, if that happens where it goes to the date, 3 to 5, what you're going to have to do is you're going to have to highlight this. You'll have to right click. You have to format the cell and just click on text. All right. For some reason, sometimes they default to something else. All right. So it should work there. So let me do that again just to make sure everybody's okay. If for some reason it defaults to like a date or a currency or something like that, what you could do is you could just highlight a column. You can right click on your mouse and then you click format cell and then just click on text. Okay, so that'll be 3 to 5. And then 6 to 8. And then from 9 to 11. And you guys get the idea here. And then from 12 to 14. And then from 15 to 17. And then 18 to 20. And then we're done. All right. Now, to figure out the frequency, all you're going to do is say equal count A, and you're just going to highlight the observations that are 1, 0, 1, and 2. Equal count A, and you're just going to highlight the observations between 3 and 5. All right. So that way you don't actually have to sit there and count them. Okay. Excel will do the counting for you. So this count A function is actually really helpful. Okay. So we're going to go from 6 to 8. And we get 6 of those. And then equal count A. And from 9 to 11. All right. And of course, you guys can just count them, right? There's 2 observations between 12 and 14. There are 3 observations between 15 and 17. And then there are 2 observations. So if you just want to count them, that's fine too. Okay. Sometimes I do both when I'm doing it. Sometimes, like if it's only a few of them and I can really easily see it, then, I don't sit there and do the count A. Okay. All right. Any questions about being able to construct the basic frequency distribution? Okay. And then the next thing we can do is we can get the relative and cumulative frequencies. Okay. By the way, once you get this, the rest of this is pretty easy. So actually, we've already gone through the hardest part of the assignment. Okay. So the relative frequency and the cumulative frequency. Notice you can drag the cells and make them wider if you want to. Excel does not check for spelling though. Okay, so be careful with that. All right. So relative frequency, we know that the sum was 27, right? I don't know why n moved. Remember we got 27 before. So that's weird. Maybe it's because I moved things around. All right, but remember we had 27, so this would be equal to 5 over 27. And this would be equal to 5 over 27. And this would be equal to 6 over 27. Okay. And this would be equal to 3 over 27, etc. Now, oh, go ahead, Kay, please. Oh, fix the number for 18 to 20.
Yeah, there's There's 3 numbers between
Thank
18.
you. Good spot. Good thing you can count. Oh, I see. And Jeff or Luke, you saw it too. Okay, thanks to both of you guys. So sorry about that. I was in my own Excel world and I was just typing things. So good spots. I want to show you guys another way that you can do this pretty easily. All right, this is pretty cool with Excel. And you could, I mean, you could just type them all in. But another way you can do this is you can take equal, and then you just click on the 5 over here, divided by 27. Then what you could do is take this box right here, and you could just drag it. And it'll actually give you all of the relative frequencies as well. Okay, so Excel's really good at remembering patterns. So what it does is it says, okay, well, I took this first one, I'm going to do the same thing with all of them. So let me do that again, just so you can see it. A shorthand way of doing it is saying equal, click in this cell, divide 27, hit enter, and go back up, and then just drag this down, and it'll do all of them for you. Okay. We know the first cumulative frequency is just going to be this right here. So I'm just going to do that. And then I'm going to say equal. And to get the next one, it's going to be this plus this. Once I do that, I can drag this and do the same thing. Okay. So again, Excel's really smart. It'll go through and do everything for you as long as you know like the basic programming of it. Of course, you guys can just do it by adding things up too. So let me do that again just so you guys can see it. Okay. So for the first one, we're just going to copy that cell. So I'm just going to say equal, click in this cell and hit enter. Then I'm going to say equal this plus this, right? That's how we get a cumulative frequency. We just add up the previous cumulative frequency in the next one. Once I have that, I drag my box down and I get all of them. If you want to make all of these percents, what you could do is you can highlight these, you can right click, you can go to where it says format cells, and then click on percentage. And you can put the number of decimal places you want, 1, 2. I always go 2, and there you go. All right. And then you can center it just like in Word. All right. So now what you guys have is you have a really good looking frequency distribution, right? This could be something that you could put into an Excel report. So if you're doing like a lab report, or if you're doing something for like a psychology class or your education class, you could take this and just cut and paste it into your Word document. Okay, so it's actually pretty cool that you can do this. All right. So any questions I can answer for folks about how we're going to go through and get the frequency distribution? And once you've got the frequency distribution, that's the toughest part of this assignment. Okay, so I'll pause, see if there's any questions. Okay. All right, friends. So now that we have the frequency distribution, we want to make a histogram out of this. Okay. The histogram is really easy to do. Okay. So to do the histogram, what you're going to do is you're just going to highlight this data. Okay, so you're going to highlight the class and the frequency. You're going to go up to where it says insert. And I'll do this again. So if you don't get it the first time, no big deal. You're going to click on this. You're going to go to insert. You're going to go over here to this insert column or bar chart. Okay, so I'm just going to click on this. And then I'm going to click right here on this 2D column. It's the first one. All right. Now, this is sort of a histogram, but it's missing some labels on the axes and the bars are not together. Okay, so I'm going to fix that in a second, but let me do that again just to make sure that everybody's okay. So what I did was I just highlighted this data. I went up to insert. I went over here to this bar chart and I clicked on the upper left-hand corner chart. Okay, now to fix the bars, okay, to put them together, what you guys are going to do is you're going to right click on your mouse. Okay, so you have a left click, which almost everybody uses all the time, and then you have a right click. You're going to right click, and then you're going to go down to where it says format data series. See over here where it says series, or it says gap width, you're going to make the gap width 0. And there you go. You get a histogram out of it. Okay, I'll do this again. Right? So to close up all the gaps, you are going to right click. It doesn't matter what bar you right click on. Go to format data series and close the gap width. Okay, so you're going to make it 0. Okay. All right. Then what you guys are going to do is you click on the graph See this plus sign right here? You're going to add some titles. Okay, so this is going to be our malfunctions. And over here in the axis title, you're just going to type frequency. Okay. And then the chart title, this was the number of malfunctions per day for, I think it was machine A or something like that, or at plant A. At plant A. All right. By the way, this is just like any other sort of graphic now. So if you want to make this image bigger, you can. All right. Again, for those of you guys that have to do like reports for projects for like, a sociology or a psychology class or, a science class or something like that, this is a really easy way to put this into your stuff. Okay. All right. So any questions, folks, about a histogram? It's not meant to be too difficult. It is what it is. Okay. Another thing I'm going to ask you folks to do is to get some box plots for the data. All right. And I'll show you, first of all, I'm going to show you guys how to get a single box plot. Then I'm going to show you how to get side-by-side box plots. Okay. You might remember last week when we did box plots for male and female shoe sizes, right? And we had like a male and female comparison. And we were able to see that the median value for the male shoe sizes was higher than the female median value and all other Q1, Q3, those sorts of things. All right. So let me show you how to get a box plot. It's really easy. You're going to highlight the data. You're going to go to insert. You're going to go over here. All right. Actually, I'm sorry, I lied. You're going to go right here. Hold on. Maybe I'm lying to you guys. I don't know where it is. It's supposed to be a histogram. It's supposed to say histogram, but it doesn't. Oh, this is embarrassing. Oh, all right. I think it's this one. I don't know where it went. It ran away. Well, if I can't get it to you this time, I'll make sure I show it to you guys next time, but or column charts? Huh. Okay. That's weird. I don't know what happened to it. It used to have like an option up here for histograms, and then it just kind of went away. So I'll figure it out and I'll show you guys one Monday how to get the histogram out of this. So I do apologize. Don't know where it went. Weird. Okay. The other thing I want to show you guys is how to get some of the summary statistics. Okay. So like the mean, median, mode, 5-number summary, standard deviation, those things. Okay. So if I want to get the mean, all I'm going to do is type equal average and then parenthesis, and I'm just going to highlight the data. Okay. And then I'll hit enter. All right. And it gives me the average of the data. If I want to get the median, okay, all I'm going to do is type equal median. All right, let me blow this up so you guys can see it, so it's not small. So I'll just type in equal median, parenthesis, and then I'll just highlight the data. And then I'll hit enter. And then finally, if I want the mode, and by the way, Excel will give you the first mode, by the way. Okay, so you do equal mode, and then you just highlight the data. All right, and there you go. Okay, so let me do those again really quick. So for mean, equal average, parenthesis, all right, highlight the data. And then for median, equal median, parenthesis, highlight the data. And then finally, equal mode, parenthesis, highlight the data. All right, so that's nice and easy. All right, if I want to get the standard deviation, it's actually pretty easy to do in Excel as well, okay? So what you would do is you would say equal STDEV, parenthesis, and then you would just highlight all the data and then hit enter. All right. So remember, finding the standard deviation by hand is pretty taxing. Using Excel, it's actually really nice for us to be able to do. Okay, so let me do it again. You just type equal stdev, parenthesis, highlight the data. Okay. All right. If I want to get the 5-number summary, remember we need a low, we need Q1, we need Q2, we need Q3, and then we need the high. All right. For the low, you're going to say equal min, and then highlight the data. Okay. For Q2, or let me do Q2 because that's just the median, right, folks? So you just do equal median, highlight the data, or you could just copy the 7 from right there. That would probably make the most sense, but I'm already committed to it. And then for the high, you're going to say equal max, and then highlight the data. Okay. So min for the low, max for the high. Okay. Now for Q1 and Q3, you're going to have to use a function called percentile. I'm going to do these both a couple times. So you're going to say equal percentile, parenthesis. You're going to highlight the data. All right. And then you're going to say comma 0.25. All right. So you might have to scroll back down to be able to get back there. Okay. And what that'll do is that'll give you Q1. Okay. Let me do it again just so you guys can see how I did that. Equal percentile, parenthesis, highlight the data. Okay. And once it's highlighted, you might have to scroll back down, comma 0.25. All right. Q1 is really the 25th percentile. So this is sort of like a way around it. Okay. To get Q3, equal percentile, and then highlight the data. Instead of using 0.25, you say comma 0.75. Okay. And then hit enter, and there you go. Okay. So there's your 5-number summary out of this. Okay. Pretty easy, right, folks? A lot of those things that we were doing by hand, we could do really quickly by using Excel. Okay. All right. So, folks, any questions about mean, median, mode, standard deviation, or 5-number summary that I can answer for you? Okay. And I know I still owe you guys how to figure out the box plot. I'm sorry. I don't know what happened to it. So maybe they upgraded the version of Excel. I'm just making sure I've got everything. So I showed you guys frequency distribution. I showed you mean, median, mode. I showed you guys 5-number summary. I showed you histogram. I will show you box plot. Okay. So any questions about any of those that I can answer for folks before I show you guys the categorical data stuff? Let me go back. Okay. All right, folks. So for the categorical data is actually a lot easier to deal with. Okay. So here's just some examples of some colors of popsicles that were sold. All right. Auto fit. Nope. Oh, I see, because it did that. I didn't want that to happen. So just so you guys could see everything, but I'll just do it this way. But these are just some colors of popsicles sold in a day of July. So I want to construct my frequency distribution. So I have my category, and my categories are going to be the colors. Okay, so I have a red, I have a purple, I have a green. Oh, I forgot purple. I don't know where that went. And then I have blue, and then I have orange. All right, and let me make this, I don't know why that didn't go to the same size, but regardless. All right, then what I want to do is I want to get the frequency of each of those. Remember, folks, we can, for the frequency, you can use equal count A. Okay, so remember that function that we had, and you just highlight all the red observations. And what it'll do is it'll tell you how many red observations you have. You're going to do the same thing for purple. So equal count A. You're going to do the same thing for green. All right, so, and again, if you want to count them by hand, that's fine. There's not too many of them, but in real life, this is more accurate and also probably a little bit faster. Okay. All right. The other thing we need is we need the n. And so we can get n one of two ways. We could just add them up by using Excel. So I could do equal 20 plus 16 plus 13 plus 16 plus 19. Or another way I could do this is equal sum. So for those of you guys that really like to program, then you could just use that command. Okay, so I'm trying to show you guys like both ways of doing it. All right, but again, just use the count A, and then you could either just add these up, or you could use the command equal sum. That's the way I like to do it. It's a lot faster, and it's more accurate because you're not likely to make a mistake typing things in. Okay, relative frequency. And then cumulative frequency. We're going to do the same way we just did. Okay, so let me show you guys, just to remind you guys how to do those. All right, so for relative frequency, remember you just take each of the observations or each of the frequencies and you're going to divide it by 84, or a faster way is just to do equal, click in the cell, divide 84, and you can just drag it. And that'll give you all the relative frequencies. Okay, let me do that again just to make sure everybody's cool with that. So equal, click there, divide 84, and then just drag it down. Okay. For cumulative frequency, equal. Remember, the first cell is always the same as the relative frequency, and then equal this plus this. Okay. And then you could drag it, and that'll get you all of them. Okay. Remember, the other thing you can do if you want to is you can highlight, you can right click, you can format, and you can go to percent. All right. And then you can make these bold. So once again, you have a really professional looking frequency distribution. Okay. So again, if you want to cut and paste this into a report or something like that, you've got it. All right. Let me show you how to get a bar chart and a pie chart. These are actually pretty easy now. Okay. If you want to, do you want it in percent or does it not matter? Good question, Luke. I don't care either way. I'm just showing you guys. I know some of you are type A compulsive. You don't like looking at the 17 decimal points and you really need it to be a percentage. That's fine. Okay. I'm actually the same way. I like the percentage better, but I don't really care either way. Okay. All right. So if you want to get a bar chart, you're just going to highlight the data. You're going to go to insert, go over here to 2D column, and there's your bar chart. Okay, let me do it again. You're going to highlight the data. You're going to insert over here, and there you go. All right, and then you're going to title the graph. Okay, so these are colors of cars sold in a day, or popsicles. Probably be tough to sell that many cars. Popsicles seems to be a little bit easier in July. All right, so make sure when you guys are doing the titles, type them in there. The other thing you guys need to do is make sure you click the plus and you're clicking the axis titles. Okay. All right, so questions I can answer about that, and you guys would fix those just in the interest of time. I'm not going to do that. Okay. You can also get a pie chart, and hopefully this doesn't turn out like the box plot did. Okay, so you just highlight the data, go right here to charts. There's your pie chart. Okay, nice and easy. Okay, you can actually just copy and paste the title. That way you don't have to sit there and retype it. I mean, if you want to, that's fine. Just like any other graphic, you could expand it. Okay, if you want to, you could put the data labels in there, and that might be helpful because what that can do is that can show somebody how many observations there are for each of those. You could actually do the same thing over here with this bar chart, is you can click on data labels, and it'll actually show you how many observations there are. All right. The rest of these, like the data table, I mean, that's okay, but you don't have to do that. And these last three don't do anything. Okay. So for categorical data, that's all I'm asking you guys to do. Okay. All right. So I know we went through a lot of Excel stuff. Okay. But any questions about either the quantitative data, which is pretty tough to do, all right, with respect, and then the categorical data, which is a little bit easier to do. Okay. I'll talk a little bit more about the submission process on Monday for this. I'm assuming most of you guys just want to get quiz number 2 done. All right. And this is going to be something that's you're going to worry about later. All right. But if you guys have questions about stuff, you guys can certainly ask me for anything for help with this. Okay. When is the technology assignment due? Good question. Thanks, Haley. It's due, I think we said February 23rd. Okay. So it's going to be due after our first examination. All right. I'd like for you guys to focus on the exam stuff. And then after the exam, you can do your finishing touches on this. Absolutely. Sure. You're welcome, Haley. Okay. All right. I'm going to stop sharing because I know we're almost out of time. So does anybody have any questions about anything before we get done for today? Okay. All right, folks, I'm going to post the link to this video in the announcements tab. Okay. It's probably going to take me about a half hour to download it and then upload it to YouTube and all that stuff. So if it doesn't post right away, don't worry. I'm getting to it. I promise. Okay. All right. If you have any questions, hang out. Okay. I'll be happy to answer whatever I can for you guys. All right. If not, I hope to see some of you guys tomorrow at STEM Day. All right. But if I don't get to see you guys then, I will see you all Monday. All right. So I hope you guys have a great weekend. Take care of yourselves. 2 weeks down, 13 more to go. Have a good one, folks. Thanks, Carter. Appreciate it. Thanks, everybody. Y'all are so kind. Aw.